Hey there, I'm Red Dragon Web Design, and this is going to be episode number 5 in our series Code Wars in Assembly. Today we are going to be learning about jumps by doing the Code Wars problem even or odd. Jumps are very important in assembly. Conditional jumps and regular jumps are how you do conditionals, like if, else, and they are also how you do loops, like do while, and for. Jumps are very important, and by learning this, we are going to be able to do a lot more types of problems in assembly. So let's get to it. First things first, let's find the problem in CodeWars. Let's go to kata, and then we're going to type even or odd, enter, and we can limit it to NASM, assembly language. And this one with a check mark means I already did, so that's the one we want, even or odd. I'm going to click NASM. Actually, first we're going to write it in C, so go ahead and choose C. You may remember from our previous video on debugging that for anything complicated, it's usually a good idea to write the program in C, get it working, and then translate it to assembly. So that's what we're going to do. So let's go ahead and open a code editor. I'm going to use VS Code, and let's see, even or odd, and make a new file. In this case, we'll do version 1 for video.c. I'll just write this from scratch for you guys, the way I normally do it. So first I like to comment a link to the problem we're doing. So copy, paste, add some URLs up here, and then we'll do our CodeWars function. Let's copy what they gave us here. So constant char pointer, even or odd, int number, wrap that, int main, need that later for actually executing this. Let's get printf working so we can see some stuff in the console. We can see the output of the function. So for that, we'll include standard io.h. Then down here, we'll do printf even or odd. And then we'll do a couple of test cases. Copy that a couple times. Actually, hold on. So we need that. We need, let's see, it's coming out as a char. So let's do, or a char pointer. So that's actually going to be a string. So let's do string new line. Then copy this a couple times. That way we have some test cases. Let's do 0, 1, 2, 5, 10. And then let's do a couple negative numbers too. -1, -2. All right, it's a pretty good series of test cases there. Now let's write a function that determines even or odd. So the way that just comes to me off the top of my head is to use the modulo function, or modulo operator, I guess you could call it. As you may recall, modulo is similar to division. It is the remainder of a division operation. So let's say 10 divided by 5, or let's do 10 divided by 2. Normally that'd be 5, right? Well, if you do 10 mod 2, instead of giving you the division answer, it gives you the division remainder. So in this case, it would be 0. If you mod anything by 2 and it equals 0, that means it's even because you're dividing it by 2 and there's no remainder. And then if it's not 0, that means it's odd. So that's what we're going to do. We're going to use that trick. We're going to number mod 2, and we're going to check if it's equal to 0. If so, it's even, else it's odd. Let's write some logic for that real quick. If number mod 2 equals 0, that'll be the even case, else odd. And then now we can replace our comments and we can tell it exactly what to return. Return, let's see what the problem wants. Wants even with a capital E and odd with a capital O. So let's go ahead and do that. Return even, else return odd. Save. Let's open up our debugger here and run it. and we'll click on terminal to see the outputs. So it says 0 is even, 1 is odd, 2 is even, 5 is odd, 10 is even, -1 is odd, -2 is even. All right, so should be in good shape. I think that should work perfectly. Copy paste this into CodeWars, get a quick pass here. Test. Attempt. Bam, looks good. Let's do a final submit, and then take a quick look at the solution, see if we can learn anything. This guy's using the ternary operator. This guy did exactly the same as we did. You can also omit the else, which might be a good change to make to our code just to make the assembly simpler when we translate it. This guy uses bitwise and, logical and. So yeah, lots of good solutions here. All right, so let's simplify our code really quick and make it look more like this, because this will be easier to translate to assembly. So all we need to do is delete this else. And that should still work just fine. Execute real quick, make sure all our test cases stayed the same. Even, odd, even, odd, even, odd, even. Looks good. Great. So we will use that. So let's switch to NASM assembly. And we'll hit train again. All right. We're in the assembly version of the CodeWars problem. Now let's go into, let's copy paste this. Copy. And then let's make a version in VS Code here. Version 1 for video.asm. Paste. Save. And now they gave us some good comments here. They told us exactly what register the input would be. The first function parameter will always be edi on x64 Linux. So they commented that for us. Input is equal to edi. The output, of course, is going to be rax. And then this is new. This is callee saved registers. So these are registers we need to be careful not to use, because we need those registers' contents to not change, else they might mess something else up. You may remember this slide back from the very first video. Register preservation in Linux x64 is B register, base pointer, and R12 through R15. So that's what this comment is. And they also included the stack pointer, which is also good. You don't want to mess with the stack pointer under normal circumstances. So they're just reminding us of that. We don't want to use these registers, or if we do, we have to save them somewhere and then reload them when we're done. But for simplicity, we're just going to skip using these registers. Now that we've copy pasted our code, let's go ahead and copy paste the C version of this program into this, into the assembly version. Let's put semicolons in front of everything to make it a comment. And then that will give us a template for working on this. Let's change this to proper tabs. I like tabs, not spaces. All right, so now we can start translating to assembly. So return even is fairly straightforward. Let's go ahead and make some strings by making a section data up here, and then let's do string even, and then we'll make every character a byte wide, because that's how strings and chars work. We'll type in even with a capital E, and we'll terminate it with 0, and we'll do string odd, data that's a byte wide, odd with a capital O, terminate with 0. So now we have strings even and odd that are equivalent to this and this in the C program. So now if we want to return even in assembly, what do we want to do? We want to move rax, the return register. We want to move the pointer to string even. Space this out a little bit. So that's the equivalent of return even. And for odd, move rax string odd. Cool. So we've written most of the program now. We've written 2/3 of the program. The next thing we can do is we can take this number mod 2 statement and we can put it on its own line. In assembly, whenever you have expressions, especially complicated expressions with multiple things going on in them, you want to split them up into their own lines. So if this was number mod 2 plus 8 times x or something like that, every single operand should be put on its own line. It should be reduced to a single instruction that does something else to a register. Luckily, it's just number mod 2 here, so let's move this to its own line. I guess it'll be int x equals number mod 2. And then here we can change this to x. Alright, so how do we do number mod 2 in assembly? Well, you may have seen it extremely briefly on a slide from the first video. It's in this division section. You actually use the div instruction or the idiv instruction. And in order to do mod, you just do division and then you read the value of the D register. Whenever you do division in assembly, you start with the first number in the A register, and then you divide it by another number or another register, be using the div instruction. And then the results of that is placed in the A register, and the modulo of that is placed in the D register. So let's go ahead and write out our div instruction. So first we want to put into the A register the first number that we're dividing. So we want number in the A register. So we're going to move EAX and then number. Number is going to come from EDI. And then we're going to do we want signed or unsigned? We want signed. So we're going to do idiv 2. So that will modulo number mod 2, and it'll end up in the D register. So we'll make a comment here. EDX is going to be number mod 2. In other words, X. Let's move this down here. That's actually not in the right spot. We can move this comment up here. EDX equals number mod 2, which equals X. All right, that's kind of our first draft of how we want to do this modulo instruction. And there's two things, though, that we need to correct for. As you may remember from a previous video, you cannot divide by an immediate value, by a constant. So we actually need to put this into its own register. So let's use another intermediate register. Let's use R8D2. And then let's do idiv R8D. Why did I choose R8D instead of R8? Because D stands for double word, which makes it 32-bit. So that makes it match this E here, which is also 32-bit. Okay, so that solves our first problem. Our second potential problem is that multiplication and division, well, especially division, they do A register divided by whatever register you give it, but they don't just do A register. They also combine it with D register. That way you can do division of an extra long number. So they take the contents of the D register, they concatenate it with the contents of the A register, they combine them, and that is one big number. And then they divide it by whatever you feed it, by whatever you give it. And then after all that, it puts the answer in the A register and the mod, the remainder, in the D register. With all that said, you usually just want to use this A register, but you need to make sure to clear the D register because you don't want it affecting your A register number. So before we do this division, we need to clear the D register. And remember, there's two ways to do that. There is move EDX 0, but the way people usually write move something 0 in assembly is XOR EDX EDX, XOR itself. That is a faster way to clear a register and set it to 0. So, with all that said, that should be working now. I know it's a little confusing. Sorry, it's not straightforward. Now we can tackle this part of the problem and the object of today's lesson, which is jumps. and that's how we're going to do if, elseif, else. That's how we're going to do any kind of loop in the future. Today we'll focus on just if, else. So the first thing you need to do a conditional in assembly is you need to use the CMP instruction. That stands for compare, and what that does is it takes two registers. So let's say you have RAX and RBX. It will compare those two registers. What does it do exactly? It actually subtracts RAX from RBX, and whatever the resulting number is, it will set a bunch of flags. And there's a special flags register that has things like, is this number 0 true or false? Is this number negative true or false? Things like that. And this comparison subtracts, it takes the difference between two registers and it sets all those flags. And it's actually very clever because it uses those flags to evaluate all the possible conditionals, greater than, less than, equal to, not equal to. It's really very clever how they did it. So that's the first thing you do. You do a compare instruction, and then after that, you do a jump. Jump if you do what's called a conditional jump. So here's the table of conditional jumps. There's more than this, but this will cover the basics. So JG, jump if greater than. JGE, jump if greater than or equal. Jump if less than, jump if less than or equal. Jump if equal, jump if not equal. Those are the signed versions. And then for unsigned numbers, they use a different instruction. JA, jump if above. JAE, jump if above or equal. JB, jump if below. JBE, jump if below or equal. Now these are exactly the same, they just gave them different names. So the first thing you'll want to do if you are doing an if in assembly, you want to do that compare instruction we talked about. And then the second thing you want to do a jump if afterwards, a conditional jump. You want to use one of these. Jump if greater than, jump if greater than or equal to, etc., etc. So let's code out that compare instruction in our program. So we want to do CMP compare. What do we want to compare? We want to compare our x to 0. So the way we do that, we figure out where we stored x. We stored x in edx. Remember, because we did the modulo, and the modulo result is in edx. So we want to compare edx to 0. Now, if edx is equal to 0, we want it to proceed to the next instruction. If edx is not equal to 0, we want it to jump. We want it to go to this instruction after and skip the first instruction. So how do we do that? You might think we should do something like, if x is equal to 0, we want to use jump if equal. So JE, and then you need to put the label that you want it to jump to afterwards. So let's create some labels. This is just hypothetical at this point. So this is not going to be the actual code. We'll just create a random label here. Random label. So we're going to compare the D register to 0. And then we're going to jump if they're equal to random label. If you see something like if x is equal to 0 in C, it might seem like the best way to write that is to use a jump if equal, right? Because they're both equals. But what ends up happening a lot of the time is you actually want to do the opposite sign. So jump if not equal, because of how we want to do our program flow here. So let's delete our random label, and let's replace this with, let's add some other labels here. Let's add if statement begin, if statement end. So we compare x and 0, and if they're equal, we want it to proceed to the next instruction. And if they're not equal, we want it to skip this instruction entirely. So the best way to do that is to check if they're not equal, and if so, then we'll jump to if statement end. But if they are equal, we don't need to jump at all. We'll just go straight to this instruction. And then quick review of what we're doing, it's a return. So because we're doing a return, we're going to want to jump there. We're going to want to jump to the end. So we'll put a label return. And give this a tab because that's kind of in parentheses. And then we will do a non-conditional jump, a regular jump to return. Or to keep things simple, you could just put a return here. All right, that was a little bit confusing to explain. I hope you guys are doing all right. I hope you're following along okay. Let's try pasting this code into CodeWars and see what kind of errors we get. So copy paste, test. Ooh, passed on the first try. That's what I like to see. Attempt. There we go, we passed. I feel like even with all that explanation though, it was still a little bit confusing. So let's go ahead and step debug this. And I'll try to explain exactly what's going on. Maybe that'll help you guys visualize everything. So we copy paste this into SASM. And we feed it some initial data. So let's go ahead and make our input number the number 3. So we're going to try to figure out if 3 is even or odd. Go ahead and compile and debug. Then we'll hit F11, move EDI3, that just sets up our test case, RDI3. Now our first instruction, we're moving 3 into the A register in preparation for doing mod. We need the A register to be 3. We need it to be number so that we can do our idiv instruction. A register 3, looks good. Now we're going to move the number 2, our second operand here, into the R8 register. So pay attention to R8 here. That changed to 2. Now we're going to make the D register 0, because remember, whatever we mod, it's going to take EDX concatenated with EAX, and then it's going to mod whatever that is by 2. So we want to make absolutely sure that the D register has nothing in it. It has no junk data from previous operations. Right now it does have some junk data, so we're going to 0 that out, change to 0. And now we're going to do our sign division. We're going to take the A register, we're going to take the D register concatenated with the A register, and we are going to feed it, this number 2. And what that's going to do is that is going to put the division result in A and the modulo result in D. So 3 divided by 2 is 1, and 3 modulo 2 is also 1. So both of those registers have changed. And now we're going to do our comparison. We're going to compare x to 0. We're going to compare the modulo result, this D register, to 0. And that's going to change some of our flags in this flags register. Now we're going to take the results of that, and we're going to check if it's not equal to 0. If it's not equal to 0, we want to skip our conditional here. We do not want it to go into these braces. But if it is equal to 0, we won't do anything, and we will let the code continue into these braces. So in our case, this D register that we compared is not equal to 0, so it should jump over these 2 instructions, and it should go to if statement end. And then in that case, it's going to move this odd string that we declared up here, this S odd string, into our return register, A register, and then we'll return from our program. Hopefully that makes things a little bit clearer. That is exactly how our program is working. Let's take a look at the solutions for this problem. We'll do our final submit. We'll view solutions. So this first one, they use a test instruction. Test is a way of doing compare, but it uses logical and instead of subtraction. So we'll talk about that later. But that is one way to do it. You can test for even or odd by doing a logical and operation. You can use a bit mask that eliminates all except for the bit farthest to the right. And if that bit is 1, that means that the number is odd. And if that bit is 0, that means the number is even. So there's going to be some answers here that use logical and type stuff. So that's one of them. Here's one that uses logical and it also uses a trick with Leia, which is load effective address. So that one's very clever. I voted that one is clever. This one, another logical and. Looks like that is the shortest way to do this type of problem. So we can keep that in mind in the future. We are always striving for the shortest code possible. This one looks quite long. I don't think all of these XORs are necessary. Remember, XOR register just sets the register to 0. And then here's my old solution that I typed up when I first did this problem. That's all I have for you today. that was quite a bit to cover, so I think I'll do another video after this one that also focuses on jumps to kind of reinforce everything we learned. If this video helped you even a little bit. If you enjoyed the video, please like and subscribe. Thank you for watching. I'll see you next time.